All right. Hello. So I'm going live to YouTube right now. I'm going to kill this. I'm going to start our little chat. And I'm just going to get right going. Great. Okay. Kill this stuff and that. Alrighty. So what I've got is I'm recording right now on a camcorder that I bought some years ago when I had money, and even, well, actually I say I had money. I actually used some of my superannuation, which in other world terms is like my retirement fund. I was able to access that early during COVID, and I actually bought this camera for some crazy reason because, you know, that's what, I don't know, COVID was, those real hard lockdowns in Australia was a very interesting time. So this camera can transmit MPEG transport stream over raw UDP. And that's what's actually happening right now. So this camera is going over the Wi-Fi, 2.4 gigahertz Wi-Fi. It's writing an MPEG transport stream to a computer over there, which is receiving the stream. And yeah, actually it's OBS, and it renders a nice little screen with the text and this and that. The thing is that there's quite a delay. Like let's say the glass to glass latency is very high. Like it's something like, well, depending on how I do it, it's somewhere between like a second or like 2.5 seconds, which seems a lot. What I want to do is actually look at the stream that it's writing, like the stream that it's transmitting, and just try and see if there's anything weird there. We've written enough code to be able to do this, right? So we've written MPEG transport stream stuff, so we can dig into the stream like that. We've also a PCAP package, so that means that we can, for example, do a TCP dump, read the packets over the network, and just have a look exactly what it looks like with the UDP and everything. Maybe there's something weird there too. I don't know. And yeah, just, overall, like actually really use our package to write, small tooling, not like big FFmpeg crazy commands, just small, tooling using the packages that we've got to, basically just dig in and see what happens. So in preparation, I've actually already done I've taken a packet dump of this thing. So I'll just show you that. PCAP, I think was the one. Yep. Okay, so lots of packets. I think it was about 15 seconds of video and audio, something like that. But, ooh, okay, yep, lots, okay. All right, so while that's rendering. Oh, my poor computer. Okay, hold up. There we go. Oh, hey mate, how you going? Hey. Good evening to you. Happy Sunday evening, right? Yeah. Ah, shit. Whoopsies. Sorry, my bad. Let's try again. Great. Okay, we're back. I'll put that up here. Stuff down here. All right. So as I said, let's just look at the MPEG transport stream stuff. Oh, or not. Streaming. Hello, hey, how's it going? Okay. So, MPEG transport stream consists of packets that look like this. There's a whole bunch of other fields in the packets that we're not dealing with, but for a lot of the stuff that I think we're about to deal with, we've definitely got enough here to go with. So what I want to do is, for example, go and try and do this. Oh no. Oh, yeah. There we go. There's our G's. So this is, if we have the PES packet, I think it is, ID. No. Oh, yeah, no, okay. Basically packets are going to look like this. So what I want to do is just kind of have a look at this thing properly and just like, you know, just maybe just start with like just printing out the packets. So I have a PCAP file here which contains MPEG transport stream packets in UDP packets, right? Every single packet is 144 bytes or something. 188 bytes. So that makes it nice and easy to work with too. Every single packet, like MPEG transport stream packet, starts with this particular byte value. So it's a G. Excuse me, capital G. And we can see our G's here. G, 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 G. So TCP dump doesn't know how to, decode MPEG transport stream. Something that does know how to is Wireshark, which I have. Yep. Okay. So we could use Wireshark, right? It's totally fine. Awesome program. Go to cam. Okay. See a bunch of stuff here. But it just kind of reads the information, right? That's all it's doing. We want to write a little program that reads information, but we know more. We want to know more about like the actual MPEG transport stream itself. There's some interesting tooling around. One of them is called TS-Duck. Of course, FFmpeg can, read and decode MPEG transport streams. There's a bunch of other tooling around. I'll just show you these just so. I've worked with these in the past or not worked with them in the past, but yeah, anyway. So this is written all in C++. Lots and lots of little tools in there that do all sorts of stuff. I think there's a list of the commands that it provides somewhere. Utilities, here we go. Yep, see? So this is pretty small text. I don't know why it's so small. Anyway. Okay, so we got analyze, bit rate, compare, right? Blah, 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 all this sort of stuff. So I got a feeling we want something like this. The thing is that, remember that this is all written in C++ and FFmpeg is written in C. So we've written something in Go, which is cool, right? Because we can sort of work with stuff a little bit more easily and, without all the sort of C tooling. So I'm hoping that it should be pretty easy to write some of these little commands that'll help us like understand maybe what's kind of going on. Interesting, I see some issues here. Okay, let's have a look. So let's keep this here for now. And a long time to see it. Laggy day, cam lagging every 3 seconds. Man, okay. This is This is really why, why I'm actually doing this, right? This is the camera lagging. So, yeah. As long as the audio is okay, I'm hoping that, but yeah, let's. Okay, awesome. All right, that's good. Nice. Okay, thanks. Yeah. All right. Well, let's see how we go. Okay, I'm gonna start a very boring program called TS stat or transport stream stat, and I don't know what it's going to do, but let's just start writing out some stuff. Good time, good test of our documentation. Let's see if we can actually use the thing that we wrote, right? It's over here. Let's make this small. Let's put that. Correct. Bandwidth is definitely not a problem. The network itself is okay. Right. So I've got all like, it's something to do with this. I'm pretty sure it's something to do with this camera, and yeah, it's to do with this camera and the way. Yeah, I don't know. I don't know. Just something to do with, yeah. Yeah. So it's going to be a good little test. Alrighty, so here's our the sample rate down. You mean of the video? Okay. Let's do decode. All right, here we go. So a scanner. This is, yeah, is here. This is what we want. Okay. So we're going to set up our scanner to read from. It's something to do with the transport stream itself. I'm pretty sure. I think partly what's happening is the something to do with the way that, well, we'll see. Anyway, let's see, because I'm pretty sure, yeah, like it's something to do with the transport stream itself, and I think it's sending the packets like out of order, and I think the receiver is having a hard time reassembling it, but I'm not sure yet. But this is what I want to see. So this is us actually going to, we're running the tooling to debug it right now. So what we've got is we've got a pcap file. So let's first like decode that and grab the bytes out of there. So we got a pcap, right? So we've got to read from, I'll just do, this, and then Yes. Well, yes. So Wireshark is right here. And I'm starting to see some interesting, problems already. But yeah, it's going to be interesting to see. Like I see red lines, and I've also seen the packet. If I go. Yeah, I see missing. I've seen this before, like I've seen a bunch of missing stuff, but yeah. And also this is kind of, I guess, like this isn't right. Like this isn't so much to fix the camera, right? I mean, I could just run an HDMI cable, like 3 meters along the ground, but because we've been writing all of this, all of this code to deal with transport streams and all of this stuff, it's like, okay, well, let's see if it's actually helpful. Instead of dealing with, these other existing software, let's see if we can do it just in pure Go with the stuff that we've written, with, just kind of live on stream, right? Okay, so first up, let's read this PCAP file, as I said. So let's just hide that for the minute. And let's read, so we've got a little PCAP package here, and let's see how to open this. Okay, so that's our first problem. We're not even exporting the decode functions, right? So like I can't, okay, so that's, yeah. So encode, okay, so let's, okay, yeah, okay. Let's see how this is fine. Oh no, let's just keep it like that, okay. And then I guess encode is gonna be like that, but that should really write to a writer, but anyway, let's keep that for now. Okay, there's decode, all right, so let's do this. pcap.decode from F. I hope you're not replacing a driver. I hope I don't. This is where GPT can't help you either. We really aren't going to replace just yet. Yeah, large language models, this is a thought exercise, right? This isn't, the solution to this, right, is to just run a HDMI cable over there. It's totally fine. But, that, right? That's no fun. Why? Okay. So from here, it's using Wi-Fi, so 2.4 gigahertz Wi-Fi. Yep. And specifically, it's transmitting H.264 video and AV. What do you call that audio? AAC audio, AVC audio. I always get mixed up. Yeah. So what's happening is we're going to be reading the MPEG transport stream and having a look at it. So we've got a packet dump already. Let's just have a look. So cap. All right, so from there we've got this header and packets. So what's in a packet? A packet has a header and data, and the header is the time and the original length. Okay, all right, so maybe we're going to have our UDP header in there as well. So maybe we can just like slice it off or something, but let's just have a look. Yeah. pcap. Packets, right? Yeah. Let's just do something really, really silly. Right, of the p.data. Okay, all I'm going to do here is write out. Actually, let's have a look at Wireshark because I'm not familiar with how UDP works. But basically, how many bytes have we got there? Is it always a fixed size? One, two, three, 1, 2, 3, 4, 5, 6, 7, 8. 8 bytes. This will error, I think. Go on twice. No, because we're doing an if, so it redeclares it. Yeah, but okay. Blah blah blah. Let's just do something really. So we're going to go from 8 onwards. All right, so we're just going to slice off the UDP, and what we're going to do is we're going to stream this thing right into FF Play and see if we get the video. Okay, so here we go. Open this up. Okay, let's go. That, and then we're going to do that, and then we're going to pass in the camera, the packet capture, and we're going to go, and then we're going to read that into FF Play. And, oops, input file must be specified. Oh, whoops, yep, there we go. All right, read from standard input. Nah. Oh, what? Input file, I did that. Okay, not quite. Okay, let's do this in a normal terminal. Okay. What we need to do. Okay, instead of doing that, let's actually just write it to a file. Maybe corrupted packets, but I don't know if I'm slicing the, I don't know if I'm slicing off the UDP header correctly yet. So I'm just going to see if I'm, and then, I'm just going to write it to a file. Okay. So now let's see if I can. Okay. All right. Probably not. So let's have a look at this again. There's all that stuff as well. Maybe I need to slice off all the... I'm not exactly sure how... Looks like I'll need to slice off more than the... I can slice off all of the, like everything up to there, right? So 41 onwards, say. Or I can go, is that going to be the same? Yeah, yeah. Oh no. UP checksum, and then bang into... Okay, maybe I can do that. Maybe I can just slice off the 41. Right, so like what I'm looking at is I've got a whole packet, including like the link layer, the IP, the UDP, and then I've got the actual payload, which is the thing that we care about. So let's see if we can just do that. I mean, this is very quick and dirty, by the way, right? So 40. So I want 42 onwards. No. Now the only other thing is that this may not work anyway because... Oh, anyway, let's see. I'll just do that. All right, that's fine. What I'm going to do is I'm going to recapture the output because I think in my packet capture I only set, I think, what is it, like how do you do it again? You do well, I can actually just print the header out. F, OS is. Yeah. Okay. So I've only captured 116 bytes of each packet. I want to get a lot more than that. I want to grab, all of it. So the command I really want to run is something like my interface is RE0 and I want to go UDP port, I think -S, is it? -S, okay, so -S, I'll just do 1500. So I know that I'm getting all the bytes. And then I'm going to write that out to, this file. And then the stuff that I want to filter for is UDP. And then I'm doing port, I think like 1670 or something like that. I don't know. I can't remember. I'll have to have a look at the camera. And then I think I'll have a good capture. Now that means that I need to I'm going to lose audio, or you're going to lose audio and video for a sec. So let me run that. Yeah. Okay. And then, yep, you'll see the screen do something, I guess. And then, yeah, I'll be back in a sec, all right? Let's see. If I do, oh, let me do it like this. Oops. All right, let's see. So there's my computer. All right, okay. Bye. Okay, hello again. So hopefully, if that all worked, whoops. Yep. All right, let's see. So you should be able to. Oh, you're gonna be fucking kidding me. What the fuck? Oh god, my power cord just went into my. Oh no. Okay, wait 2 seconds. My camera's power cord fell into the cup of tea that I believe it. Fucking believe that? That is fucking ridiculous. Damn it. That is, and this is like some, you know, it's some proprietary connector, right? Like some proprietary, you know, Sony stupid power cable, blah, blah, blah. What do you think? Is that going to work now or not? What do we think? Let's try. That's fucking ridiculous. Well, I can't actually tell, but anyway, whatever. All right. That are off are okay. Just let it dry. If like just flame through, that's a different story. Fucking hell. Can you fucking believe that? Let it dry. If electricity is flowing through, that's a different story. Okay, maybe, should I turn it off maybe? I don't know. It's just the... Hey, how's it going? All right. Okay, let's get that. All right, so Okay, let's check it's okay in here. How do you do that again? You like, all right. Oh. Alrighty. There we go. This looks better, right? Because we've got, yeah, see? Looking better. We've got the whole capture now. Okay. Let's hide this. Sorry, I'm just a bit pissed about that plug. Let me just see. I'm just going to turn the stream off for a second, just make sure that the camera's working or something. I don't know. Sorry, I just realized that I'd broken the stream. I assume you can hear me now okay? Could you hear me before? Was I just speaking to nobody? Oh no. Oh man. All right. It's okay. All right. I'll just explain what I'm looking at here. So what I want to see is I want to see this basically for every packet. It should be, incrementing one at a time. Because otherwise somebody at the other end needs to like reassemble it, right? So the decoder needs to say, oh, well, Yeah, exactly. I know, totally useless. But yeah, so what I want to do is just kind of have a look and see what is going on with this thing. So we're going to just grab like 1,000 packets and see, yeah, because I noticed something in Wireshark there. So let's just have a look. So I'm going to read from the TimCam. Okay, interesting. So we need to split these up. So we've got, okay, this is a good, interesting bit of info, right? So in each UDP, like in each datagram, they've pushed in 7 MPEG transport stream packets. So we need to kind of go through and like iterate it ourselves. So how we're going to do that, I think, is using a scanner. Or I can slice it myself, but I really don't want to do that. How am I going to decode this? I've got 42. I might have to load the whole thing up into memory or something. Just do a quick and dirty one. Yeah, let's do that. All right. Okay, so I'm going to load it into this buffer and then decode everything afterwards. Okay, bad code here, bad code, but it's fine. Okay, now we're going to do a scanner. MPEG-TS .new scanner. And what a scanner does is it can scan incrementally through the transport stream, just the same as in the standard library. We've got the buff.io scanner, which sort of like helps you scan through text or like other types of stuff. This one is just actually like a little wrapper around the buff.io scanner that deals with transport stream packets. So I found this pattern really useful. you know, and this doesn't just apply for MPEG transport stream, you can use this pattern for a bunch of other stuff. Okay, so we're going to create a new scanner from our bytes buffer, and then so for sc.scan, now we're going to go through and we can actually just do the same thing again, right? So we're going to the sc.packet.continuity, and then we're done. So we're gonna if sc.bird does not equal nil, then like that. All right, try again. Unmarshal. All right, why haven't I? Where's my? Oh, that's here. This is because those first few packets are actually like something else entirely, right? So we saw this in what is that going all the time? Try again, shall we? Yep, so it's those first few packets there. So we can just check. Let's just filter out the ones that don't have that length. To our pcap package, global header packets, Yeah, that's right. Okay, so we're going to do, so for each packet in our packet dump, we're just going to check that the length is, 1316. So we're going to go, right, that's what it is. So then continue. I'm going to let's try again. All right, so run, and then we go oh, header, is it? Right. Okay, is that done? Now we can try, let's just, for fun and games, let's just try and play this thing again. Oh yeah, we're not doing that anymore. Yeah, great. Okay. All good. Let's do that. So why aren't I seeing any? I'm expecting to see the stuff being printed out here, right? Like I'm reading from the buffer, I'm writing all of this stuff into it. Yeah, I think so. I think so. Well, I mean, like, actually, like Acme does, like Acme itself has that, right? Like it has a, it has the, because it's just a file to Acme, and Acme itself has this like backup mechanism. But yeah, so really what I should do is load, Acme has a flag, like you load it from a dump file and then it just restores your whole environment for you, but I can't be bothered. It's because I accidentally exited Acme. Yeah. But you're right, I should probably, yeah. So very interesting. Oh, because I'm not. Oh man, what am I doing? Look, like the only thing I'm writing is that I'm piping it to nowhere. Okay, here we go. There we go. All right. There we go. Okay. Here we go. Okay, look at this. 1, 2, 3, 4, 6, 7, 8, 10, 11, 12, 13, 14, 8, 9, 10, 11, 12, 13, 14, 15, 0, 1, 2, 3, 4. Okay, look at that. So that's pretty messed up, right? Now that... Okay, great. We're getting somewhere. So when we... Right, so... 0, 1, 2, 3, 4, 5, right? Because it should go all the way 0 to 15 and then go right round again. That's all it does. It's not doing that. Sometimes it does it. But then it's like, so 0, 1, 2, 3. And then it just starts again. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Blah, 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 blah. 0, 1, 2, 3 again. 0. 0, 1, 2, 3, 4, 6, 7, 8, 9, 4. 4, 5, 6, 7, right? So it's still... So that's not really like a... It doesn't seem like a happy transport stream. Now, there's more to it than that, though. Like, what we should look at is the... let's look at this. So we've got this continuity, but I think we also need... We need to check for that. If I remember rightly. Because you can have... Right, like you can have different... I think you can have different packet types, and then the continuity counter will be different between them. So let's have a look. So let's do this. So sc packet dot PID. And what I'm going to do is I'm going to set this up. There we go. All right. 65. What do we got? So 65, 0, 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13. And then it's just back to 0 again. 13, 15. Okay, that's all 65. So let's do this, but instead, let's grep for 65. Okay. Okay, so we've got some... Thirteen, 14, 15, 0, 1, 2, 3, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 0, 1, 2, 3, 4, 6, 7, 8, 6, 7, 8, 5, 6, 7, 8, 9, 10, 11, 12. So there's almost like some... So we've got discontinuities. 0, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 7. And then back down to now 1. And then what happened to 0, right? 1, 2, 3, 4, 5. So there's that's happening. Adaptation. Let's have a look at that. Discontinuous, okay? So let's check this discontinuity thing, right? Because this field in the MPEG transfer stream header is there to help players adapt with it. So for example, like if the thing knows that there's been, you know, there's going to be some discontinuity, we'd hope that there's a, that it's marked as such, that the stream's discontinuous. Now, it may not be because because the camera doesn't necessarily know that the stream is discontinuous. For example, if you're transmitting from like a satellite up in space, that thing isn't going to know, or an antenna up on a mountain. It does, from a big tower up on a hill, it doesn't know. But this is just one of the things that you find in MPEG transport stream to help transmission, to help receivers, decode the stream in like unreliable network conditions. Not even network conditions, just unreliable conditions. Because, yeah. Okay, so like this. If dot adaptation equal nil, I'm just gonna do. I should really do. Oh no, it's just a pointer. That's okay. All right, packet. Let's see, if I'm printing ln, okay, as dumb as that. Oops, what do we got? Oh yeah. Okay, let's run that. All right, so it looks like there is no discom. Okay, so the camera never, okay, so that's one thing. Okay, so that may be one thing that we can do, right? We can have the camera, our little bit of software in the middle that's checking for discontinuities and just setting the bit. It just sets that flag in the adaptation field and then just passes it straight back on again. So it retransmits it. That's a possibility. That might help the receivers on the other end. Oh, sorry. Let me just see this. Sorry, I just realized I was grepping for something out. So let's... No, okay, all right. So we're not grepping for anything anymore. It's just, yeah. Yeah, okay. Oh, what's this? Recent messages. Robo TTY. Ah, cool. Oh, I'll look at that later. Yeah, that's cool. Yeah. No, that's good. Yeah. I'll just save that to my No, it's good. It's good. Good, thanks. Did I work deeply with radio stuff much in your time? No, not really, no. There was a project going on that, yeah, but, nah. Do I work at a software job? No, not currently. I'm just, yeah, it's sort of, I should probably, get going again soon. But just taking a bit of a break and just seeing if I can do some independent stuff. Yeah, contracting and stuff. But we'll see. I'm just, yeah. But I have, yeah, for years, yeah. Yeah, that's right. So basically, yeah, like if it's like acme-L, I think is the flag. Yeah. It just restores all of your windows when I quit Acme suddenly, like I did. So that's one thing. Why don't we... let's grab 10,000. And then let's actually... let's write this packet also to a file just so we, can actually try and play it and see how a decoder, like a real decoder, like a player actually plays it back. Because I want to see what FF play handles it again. Now that we've got like an okay stream. So let's go here, packet, blah, blah, blah. Okay. Let's just go... oops, I want to do that there. Just run like this. Okay, we're going to write the actual transfer stream packets to this file so that we can analyze it. Again, create blah blah blah. Yeah. Then I think we can do Marshall. Encode the packet. Okay, easy. All right, so let's go encode into temp the sc.packet. That, and then we just continue on. It's not great, but whatever. Oh, there we go. A few errors there. Ah, interesting. Interesting. We have maybe some. Interesting, eh? Look at that. We're 65. Interesting. We've got some. Okay. It's all right. So we've got some errors when we encode only some very few of the packets. Yeah, okay. Might be some that looks like some bit shifting logic we might need to test. So the PCR is the program clock reference. This is a clock in the a timestamp in the packets. So it looks like we're yeah, we're getting some like huge number that's impossible to pack into the bit field that we need to pack it into. So yeah, we'll have a look at that afterwards, but let's try and play this thing now. Here we go. So there's that really fucked up video again. Okay. Now another thing we can do is, I remember reading once that FFmpeg can't. It's something to do with the way it reassembles streams. It like isn't. It doesn't do it or something like that. So what I might do is install VLC and just play it there and just see what happens. Now, why this is interesting is that this very stream right now, if I try and play it with, if I read this stream from OBS, which under the hood, of course, uses FFmpeg heavily, then the lag in the latency from here to there is like very big, and eventually it'll just like drift and it just fails after a while. I'm actually, there's a special input in OBS where you can play it into VLC and then read the stream from VLC. And that's, yeah, so that's, and that's how this is working. It's working a lot better. There's less of a latency. There's like maybe 600 milliseconds, something like that, which is still a lot, but it's okay. Personally, I like MPV a lot. Yeah, the thing is that uses FFmpeg under the hood as well. So I'm gonna see if this, yeah, let's see how this VLC thing works. Just want to see any other hints. Like, so we found one thing that we could help improve upon, which is the discontinuity, but yeah, I mean, like, Jesus, like, look at that. That's really... See, because the errors aren't just, sorry, I don't know if you can see that, but the errors aren't just, see, there's some H.264. Yeah. Got that a lot. Let's have a look. That's a really broken stream, eh? Really broken. All right. Let's try again. I've just, oh, sorry. Yep, so what I've done is I've just done the whole entire capture instead of just a little subset we were doing. Oh, there we go, there's a screen. Yeah. Let's have a look at the PES packet and see if there's anything in there that... Actually, let's look at that. Let's actually just run the... Oh, I've already got it. Whoops. Let's have a look at what's in the PES header. So one of the errors that we saw when we played this is this PES packet size mismatch. PES packet size mismatch. Nothing particularly interesting in here other than the timestamps. So packet corrupt stream equals 1. PES header? No. PES packet, I generalize this stream from other elementary streams. Length is the number of bytes for this packet. print this. I'm just going to print out the whole header here and just see if there's anything weird. Payload start. All right, let's do that. The method header. Oh. Oh, right, let's do the packet. Okay, I'll do. Okay, we'll do error, blah, 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 blah. Rotation pairs. Let's do that. Let's do this one. If the continuity, what I'm going to do is just print out the continuity, then see UN8. Okay, so I'll is a UN8. Okay, if oh no, it's 15, right? So what we're going to do is just check for the actual discontinuities. Then continuity not equal 15, and the continuity counter is not the previous one plus 1, then we've got an error. So we want, like, not an error, but like we want to, I mean, look, like we could actually set the error flag. There's an error flag on the packets. Might be interesting. Yeah, or we could actually like just set the discontinuity here. But let's just do it like this. Okay, so. Okay, let's do that. So packet continuity, so we expected previous plus 1, but we actually got sc.packet.continuity. Should probably have that as a point. Anyway, let's do that. let's not print out the whole packet anymore. There we go. Oh, whoops. Yeah, I'm not setting the previous one. Okay, blah, blah, blah. And then we go. Right. There we go. So lots of that. Now I think the packet ID needs to be the same. So instead, what we want to do is let's do a map of MPEG-TS packet ID and then to the continuity, which is going to be uint8, right? And then we can track the packet IDs and the continuity counter. I think. Just read this again. I might check the spec to see the continuity there. Continuity. Oh, no. Oh, I can do. Interesting. Cool. Within each string, incremented per PID only when a payload flag is set. Okay, there we go. All right, so it's, all right, here for this. So let's do that. So we've got our, right, packet ID. Is that the right PID? Packet ID? PID. That. Describing the payload, incremented per pack. Okay, all right. So now let's go up. So we can go. So first let's set all of the packet IDs, right? So we're gonna go, let's do PID. Okay, PIDs. Let's do let's do that. Okay. Oh no, I can just set a variable. It's fine. All right. So let's go PIDs of the p.packet. PID. Okay, so the PID equals. Okay, there, like that. So that's what we want to. That's what we want to set at the end. So let's go. If PIDs yeah. Yeah. And then now we're going to get the PID does not equal. No. Let's start again. So if the P, shit. I want to check if the continuity counter, so if p.continuity is not equal the PIDs plus 1, right? There. That's our thing. And then that is going to be that. And then that's just going to be that. Okay, and now we're going to do PID, right? We need to say which one we're actually looking at. So this is PID. Okay, there. And then we set the value. Let not use. Okay, great. Okay, there we go. All right, it's making sense. So, okay, a lot of junk. All right, so 65. Now 16, that's invalid, so we can because we're only doing a 4-bit integer, so maximum value is 16. So let's check for that as well, right? So we're going to go if the previous one I mean, we could even spell this out a little bit more. So the previous is the PIDs. Might be a bit more readable. Let's see. And we expect, right, trev plus 1. Yeah. Not equal the expected. I know, and then if expect is greater than 15, then expect is actually 0. We're going right back to the beginning. Cool. Okay, we're getting somewhere here. Okay, this is what I like about this procedural code. Like sometimes it's, you kind of, yeah, something to be said for that sometimes. I mean, if your brain works like that, like mine, it's like, yeah, okay, I get it. Okay, so now we go expect. And actually, I think that's it, right? I think that actually seems to be it, because we're saying the actual value that we got is not what we expect, and we've already worked out what we expect up here. Find that quite clear. Okay, and then we're going to go like that, because then everything else is separated out right like that. There. That's our logic there. There we go. So, I mean, there's all sorts of yeah, there's a lot of stuff going on here, hey? So for example, in the, for this PID, call it 65, whatever that means. Expected 16. Oh, whoops. We're not, here we go. No, this is the error's wrong. Okay, so PID that, expected, expect. But we actually got that. There we go. Okay, now let's grep for let's only do, so how I'm working this out is I'm pretty sure 65 is going to be the video and 66 is going to be the audio, because 65, you know, is going to be like a large, you know, there's going to be many, many, many video packets, and, you know, audio is much smaller. So let's see. So let's grab just 65. And then let's actually count the packets as well. That's sort of interesting, because then we can start like, okay. So lots of, oops, code packet. Oh. Right, so we're going along, and it's quite often, like it's every, like, you know, what are we looking like, every 20-ish packets, less, sometimes more. About every 20 packets, we sort of, the UDP packets, by the way, I think, sorry. No, sorry, no, it's every, yeah, every 20 or so MPEG transport stream packets. And I think, how many is in 1316 divided by 188? Yes, there's seven MPEG transport stream packets in each UDP packet. Looks like every 14. Yeah, seems very, yeah, here it's like very consistent. Yeah. Holy shit. I think you're right. Yeah. Close to, anyway. But every 14 is significant, because that means it's like a UDP. Yeah. But you know what's interesting, right? Yeah, so every 14, you know what? Fuck, that really lines up, right? That means every, like, second, let's get this right. Every second UDP packet is, you know, we're losing some stuff. Now, it looks like here, look at this. It looks like we're probably dropping half of them. It looks like we're just dropping like half the packets here. Something like that, right? Because we've gone up to, we expected 1, but we got 10. So we jumped ahead. So in that case, we got 0, and then so we're at 0, but then we got 10. That means we got like 8, 9 extra. So something somewhere is like, yeah. So this, to me, this just looks like boring old packet loss, partly. And I think you're right to blame Sony, because I think that, because I know that I can, well, yeah. Yeah, I don't know, yeah. Yeah. The streaming right now, this is all over UDP, right? So the actual display that you're seeing, like the network is fine. It's not a lot, I'm not getting packet loss or anything like that. Because this is like blasting the shit out of like, I'm doing 40 megabit a second sort of ish, 30 megabit, say, over the over Wi-Fi. And yeah, and that's all UDP. So yeah. Or what, megabit, I don't know, whatever this is in, like bytes and stuff. But yeah, at least for now, like we're doing 40 megabit. So the network here, it's all on the LAN, and I've got big thick walls, and I've got a unify access point, and the switch is fine and everything. So, and there's no weird old cabling or anything. So but I think that dude from Australia is onto something with the 14, isn't it? Look. Well, there we go. There's a 14. So it's like it's just missed. So it's like dropping like a lot of packets. So one thing we could do is we could actually, why don't we, like for shits and giggles, right? Let's actually have this thing write out to the transport stream file, and let's set the discontinuity header, the discontinuous, flag in the header, and see what happens. All right, so let's go here. If not equal expect packet blah 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 blah. Okay, and then let's set it now. So if okay, I can't remember what this structure looks like. Let's just see. Adaptation, discontinuous. Okay, so I think that's all we need to do. Maybe. I mean, let's just see what happens. Yeah. Okay, otherwise we just set it adaptation.discontinuous true. And to make it really short, we can actually just do this like that. Adaptation. Okay, and then when we yeah, that's it. Yeah. Okay, so let's yeah, that dude from Australia is also a you know, a fellow professional like me. So it's good we've got the right people on the stream here keeping things on track. Okay, so packet adaptation. Let's dump that. We don't need that anymore. And then let's see what that looks like. And we're still going to write out the to the file, I think. Yeah. I mean, not that it closes anyway, but you know, it's fine. All good. Oh, bug. We have ourselves a bug in our implementation. We've got a bug, right? We should never be writing 190 bytes. So there's a bug. So what's happening is that we're setting the adaptation field, that we're creating one, whatever, and then we try and encode it, but then our encoder is writing out invalid packets. I mean, we're catching it, but yeah, it's like, so in we go, right? Let's have a little test that reproduces it. Okay, here we go. Codec test, probably there is a good place. Unless it's invalid to do something like this. But I didn't think so. Let's read the code first before we start writing it. Adaptation, okay, here we go. Oh no, that's parsing it. Here we go. Whoa. Nice. Nice function. All right. Here we go. Adaptation is not equal nil. Okay, let's have a look at our this. Here, there. So adaptation. What I'm thinking is if there's any stuffing bytes that we need to get rid of, that we need to like unset. We're getting 2 bytes. Okay, and I'm pretty sure those 2 bytes, we've got 2 bytes too many, okay? And looking at this here, reading it, I can see that you have like a, we have, here we go, the A buff, right? Okay, so the buffer starts with the length, which is a single byte, and then whatever we've got here. So those are the 2 bytes, right? So there's one coming from the actual length, and then the second one is coming from here, which is just the flags. So what that means is that if we look at it like this, adaptation, this structure, okay, so we've got 1, 2, 3, 4, say, so some bytes in here. So we've got bytes for the flags. These are like, you know, Boolean flags in the header. And then we've got all this other stuff, which, now I'm looking at that, maybe that. But anyway, yeah, and then so for some reason, if we've got this adaptation field, it's not, there's probably some 0 bytes there, that like some padding that we need to get rid of or something. And then see, and then so eventually when we've built up our bytes, we're getting, you know, to here, and we're saying, hey, like it's not 188, I've got 190. Encode pairs. I wonder if there's some stuffing or padding in there. Let's have a look. So in our actual packet, right, we can have this thing. Also contains stuffing bytes. There we go. So we might need to go into there and which should be stored separately. Yeah, see, look, you know, these little things you write, like, you know, this is probably going to come back and bite me, so I'm just going to make a note of it. Fucking, here we are. Can you write a test yet? Yeah, I think, yeah. I think so. I'm not quite sure how to do it yet. Well, yeah, the struct will, yeah. Because then I can go in and, well, no, you're 100% right. No, you're 100% right. Because then I can go in and actually set it to 0 or something like that. But I'm not, I want to write the test first and then sort of be able to work out how to do it. So I think Swills is on the right, track. Yeah, because what we'd probably, just thinking out loud ahead of myself, what we could do is we could do all of this stuff, right? And then say, hey, like, say if we've got too many bytes, we can start getting rid of stuffing bytes. Of course, checking along the way how long things are, so we could just start you know, throwing things away. Yeah. So I think it'll be in here, but let's check. Because I really want to, I need to kind of make a test that has like where we're going to hit this particular case where, I mean, I'm assuming it's this, by the way, I don't actually know. What if I actually just write a really sort of quick and dirty test just to kind of get things going? So let's do test stuffing, and I'm literally just going to like read the file that we've written, or that we that how we're going to do this. You maybe read this actual thing. Yeah, let's actually just do this. And then we're going to go, I mean, it sucks, but, you know, cam.pcap. And then where are we going to write it out to? What's the null device? os.null? Is that device null or something? Oh, I know. I can just do a discard writer. Or os.discard, I think. Yeah. Okay, I'm going to do that one. So I'll just, and then let's go through now. So I'm just going to do this. So I'm just going to set the adaptation, like just set it on every single packet, because it doesn't really matter. We just want to catch the case. And then well, what's going on here? Why are we doing this twice there? Yeah. Probably, yeah. Oh, yeah, okay. And then so like cheaper to calculate how much I need at the end, if any. Yeah. I see what you mean. I mean, I'm right now I'm only assuming that this is the stuffing bytes. I don't actually know. I mean, I've kind of just assumed it, but this test should at least confirm that. And then what do we do? So then we go if MPEG-TS dot, I mean, we can actually just do, oh yeah. we just send it to nowhere, and then we give it the packet there. Then modify. Yeah, that makes sense. But for now, write test, then modify. Yeah, because I don't actually know. I mean, I've assumed that it's the stuffing bytes, but I'm hoping that I'll be able to see it here. But write everything twice. Yeah. Yeah, that's good. Yeah. Yeah, that's good. Yeah. P cap. I don't need any of that. All right, there's our, okay, many errors. All right. Let's just die after one. Packet one. Okay, there we go. Now we can check in here what the length of, like, let's poke around in the packet and see what is, you know, if there's any stuffing or anything like that. So the first thing to look at, I think, is, yeah, the adaptation field. So let's check if that's nil. P.adaptation not equal nil, then you know, just say stuffing byte is nil, and length of P adaptation dot stuffing is greater than 0. Okay, in adaptation field. Len of p.adaptation dot stuffing. Oh, missing. Oh, yeah. Ah, okay. So, no no stuffing bytes there, which of course makes sense, right? Actually, because we made one, I think, maybe. Now we've got Sorry, let me have a look. Yeah, religious adherence to drives how you had to pick. Yeah. Yeah, I think like, yeah. Okay, and then let's go here. So so there's another place where we can have stuffing bytes, and I think it's in, okay, packet we check in the PES packet in here, and then we check in the PES packet the header, and then we check in optional. Okay, so let's do that. So we go if p.pes, oh fuck, can't remember the field names. PES. PES header optional. Header optional is not equal nil. In the PES header. Something like that. Okay, so that means fuck. Oh, whoops. Yeah, we can check if it's a nil. Okay. If p.pes is not equal nil and well, what do we think? So my assumption was wrong. We've got 2 bytes from, well, I don't know, we've got some extra bytes somewhere. I don't know where. Let's just keep going. Let's have a look and see where else there's bytes, I guess. Packet. It's probably something. It'll be, how can we do this? You know what it'll be? It'll be because, you know what it is? It's the payload itself is going to have, wait, let's check. Let's go through this bit by bit. Okay, so we check the adaptation field. And so stuffing, okay, there's that. Now what's the other thing we check? We check the PES packet, right? And then the header, and there's that there. So that means that there's probably bytes elsewhere that, damn it. So there's bytes elsewhere that we can't, oh man. Yeah. So what we would need to do is maybe, see, at this point we'd need to disassemble the actual this stream, or disassemble at least part of the stream and then put it back together again. Right? because, yeah. Damn. Because the bytes can only be in here. Like, they can only be in the byte slices that... Unless, let me just read this again. Adaptation. Yeah, that's all just nothing. What about if we do... What? Okay, so that means they're already... There is an adaptation field. Oh, sorry, we've done it up here. Whoa, 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 whoa. My bad. Yeah, okay. No PES packet. PES. So packet. All right. So there's just going to be stuff in here that we currently do not decode. Okay. So what that means is that if we look at the spec, there's all sorts of different stuff that can be in there. In the PES packets, that's actually like the raw audio and video, like the actual stuff. But then there's other things, right? Like there's like metadata and stuff like that. There's things that tell you, yeah, there's just stuff. You can actually put in like, you know, markers and look at all these sorts of things, you know. Oh, the debugger, yeah. Yeah, it could be worth having a peek in the... Well... Okay, hold up. Originally designed for broadcast, later is refused to do video cameras, adding a 4 byte time to the sound, resulting in a 192 byte packet. I think that's the I think that's this one. No, it's not. It's something different. That's a good find though. Yeah. Yeah. I think I haven't. I'm pretty sure it. Yeah, actually, maybe this. See, the thing is that I don't think this camera does that. I'll tell you why. Because does 192. Yeah, no. I'm pretty sure this one just does like standard broadcast stream, transport stream, this camera. But yeah. Okay, I've thought of another trick. Okay, I can actually double the resolution of video that's being transmitted by the camera. That means the packet loss won't be as bad, I think, because right now if I lose some packets, I'm losing more video because the actual size of the video is like smaller. So if I like double the resolution, maybe packet loss isn't quite as noticeable, Maybe. I mean, like it's gonna be transmitting more packets though, so right, like the bit rate is gonna be higher. So I don't know. So there's no adaptation field and no PES packet, right? So that means I can't just arbitrarily add an adaptation field and, everything be okay. What about... Okay, well, look, like, I mean, it was an interesting experiment. I mean, like, to do that, to do the, try to set that. Interesting. Look, packet 1, and then yeah, it's dropping it. I think the device itself is just dropping packets. Like, for whatever reason, the camera can't. Yeah, I don't know. It's interesting. Yeah. So this out. Yeah. So the adding the adaptation field, and then, you know, having some error that, you know, that, hey, like this thing's too long, that's okay. It's kind of valid, like it's an okay error, because we can't necessarily just add the field and then hope that everything's okay. It's a bit of a shit error though, but it's only because like we don't support, like we don't support decoding all the different types of payloads that could possibly be in there. Nor do we support, for example, like say everything was like perfectly aligned, so 188 bytes, let's say the audio, right? You can't just like chop some out. I mean, you can, but you need to like realign everything, which is a bit more of a big deal. So yeah. We could just try chopping it off. I don't know, like it could be interesting. Fuck it. Let's, you know what? Let's just do that. Yeah? Let's just do that, just for fun. Let's just chop the two bytes off the actual the packet. Like let's get rid of the payload. Let's do this. Let's just knock off 2 bytes from there. So the payload, right? So if we've got a, let's go here, okay? And then the P dot. And where are we getting now? P dot payload. Oh no, let's go like, okay, there, see what happens. 186, okay, yeah. We get a little bit further, but then we get like somewhere else. So what we could actually do is now we could start doing our logic of like chopping out the stuffing bytes. So let's go in here, right, and say at the very end encode. Yeah, right. Okay. If the line above is not a packet size, okay, let's. Oh no, but we're out now, aren't we? Because we need a. Oof, yeah, it's tough. Yeah, that's tough. That's tough because we don't actually know like where in the where those bytes are relative to everything else. Right. So for example, we've got here. because we've written all this stuff into the buffer, and then yeah. We could do a thing where we actually like return here. We can actually return like a named error, or however you call it, you know. And then we could do a check on the error and then try and like move things around. That's probably, you know. So we could go, for example, something like this, greater than or equal to, you know, this, and we can go, okay, return, you know, return too long or something like that. Oh, greater than. Something like that. But nah, we can't, without like really extending the functionality of our library, it's going to be hard. And I don't really want to, you know, don't really want to go too deep into it. Based on like some, well, I don't know. This, you know, hardware's a bit, I don't know. The hardware's a bit interesting. It will be interesting to see what happens though. At least, because this is, you know, this is a, you know, it's okay. Okay, let's do this and see what it looks like. Empty lights. Okay, there we go. There's our error. Let's do this. Okay, we're gonna really mess around with it a bit now. Okay, errors dot if short packet. Let's go up here. We want to really only check for a long packet. So if errors dot is a long packet. Okay, here we go. Now we can start trying all again. Yeah. So let's go. If the adaptation fill is nil and len of p.adaptation.stuffing is greater than or equal to 2, then we can knock off the 2 bytes. Zero, 1, 2, so 2, right? 0, 1, yeah, something like that. Fine. Okay, otherwise, optional, yeah, p.pes. Okay, now we can really, now we actually, worst case scenario, we just slice off the, part of the payload. Just see what happens. just to see, we're gonna see. Just to see, just as a test of our, let's see what's going on. We'll just do that. Fuck it. All right, there. And then we try again. Right? So now we just go again and then we go. Right. If I send you a pair of fluorescent speedless sensors, would you go back to sunglasses on stream? The problem, I want to wear sunglasses because you know what it's like in Australia. It's bloody sunny. And my glass on the windows is very old, so it doesn't protect you from the UV. And I've got an eye condition where I've got very sensitive. The problem is that this display is polarized, and my sunglasses are polarized. So when I put them on, I can't see anything. Oh, actually, I might have some non-polarized ones. I guess I could buy some as well. But that would actually, yeah, that would actually be good. Okay, hold on. Okay, there we go. And then okay, like that. Is this actually going to work? No, we got somewhere. Yeah, okay, that's fine. All right, that's all good. Encode mangled packet. What? How did we get that? Oh, it's elsewhere. It's not even in the payload. It's going to be somewhere else altogether. It'll be here, okay? So we can just chop off some of the video or audio or whatever. So we can go into the PES packet, which contains the actual audio and video, and then just get rid of stuff. Data contain, yeah, right? So data. So we just chop off that. Okay, and then finally the really bad. Okay, so we have another. I think that should be okay. Let's see. All right, F. There we go. We got it. Looks good. Let's knock out the log. No, because I don't care about that. And then we're getting that error there, which is fine. Okay. I'm kind of interested in whether this code will work now. No, I wasn't. Yeah, I wasn't removing 2 bytes. There was another case where the actual in the packet we do support sort of partially decoding this particular type of packet, but in there we've got some opaque bytes that we don't. Yeah. So this is for even other types of payloads that are not directly the raw audio or video. For example, this can contain stuff like, I think it can contain like EPG, like the, when you go on the TV, like you have like a program guide and you can go like, oh, when does the show finish or end? And I think this sort of thing can contain that information. So what I'm doing is I'm going, okay, like if yeah. So I'm hoping that, so now I'm going to grab this code, put it into our, not there, but into our like program and just see what happens. Yeah. So we're going to go into here, p.packet, blah, blah. And then we're going to go into here. And then all of that, I think. Well, no, sorry, no, all of, this. So I'm going to go into here and then say, there, and I'll actually just try and encode it and see if I get an error, and I could just throw it away and then actually just do it once or something. So I'll do like p dot doing that up here. Yeah, I think that's it. Yeah, just like that. Because what's happening here is that we're sort of just arbitrarily cutting off stuff. And then we leave it like that. Right? And then we try and, yeah, so if it's not what we're expecting, if we're not getting what we're expecting, we just like try and set the discontinuity. But that means we may have to mangle the packet, which is here. Okay, this is just crazy. All right, so let's do this. I think that's right. Adaptation encode. Long packet MPEG-TS dot. All right. That might actually work. Okay, so now we're actually going to try and play that file, yeah? And see, like, fuck. Missing anything? We might have broken the file, which makes sense. Is this a buffer? No, we're doing it here. Okay, so okay, V codec. What about instead of slicing it off from the beginning, let's yeah, it is weird, yeah. Instead of doing it there, let's slice it off from the end. Okay. Shit. Is that long packet? Oh, we need to do that. Yeah. Whoops, whoops, whoops. Okay, hold on. Let's do. Oh. There's something with the. We're not even writing out. Wait. Where's it being written to? Oh, fucking hell. We're writing to... Damn, motherfucker. Okay, fuck. I've been reading the wrong... I've been doing the wrong file the whole time. Fuck. Okay, so I need to... Sorry, okay, so the command is in that one. I need to run this. Alright. Oh, stupid banner. There, that's the file that's being written. Get rid of that. Okay, there. Okay, let's get rid of all this. Silly, silly, silly. Okay. Well, here's our mangled, this is our mangled video, our mangled stream. So this is with like heaps and heaps and heaps of discontinuities inserted, plus like throwing away random bytes. Let's try again. This time, let's not do any of the, not take account of any of the discontinuities. So let's just I mean, okay. Let's play them side by side. Okay, we're gonna have one that is okay. We're gonna have that, and then we're also gonna have okay. So this is the one that's unmangled, and this is the one that we've tried to fix. Ready? I'm gonna go back to the beginning. So on the left is the one that we haven't tried to fix, and on the right is the one that we've tried to fix. Well, that's the first thing I noticed, right? Is that the play time is totally different. Looks like the player skips ahead. Yeah. Basically, you know, by the looks of things, we're just missing a shitload of data or something. It's just like totally busted. So, you know what that means? I think for me, that means I think that means a long Ethernet cable. No, Ethernet, I can't even do Ethernet. I need to get a long HDMI cable. Interesting though that like when you just, you know, when you like dump all of this data, like you can still sort of play the thing. Yeah. Let's try VLC with the with our fixed file. Ah, yeah, no. All right. Interesting. Another thing we can do is we can get rid of, look, let's, rather than getting rid of the beginning, let's do the same thing at the end, right? Let's do this. Len of p.pes.header optional. something like that. Wait, len of -2 and then like that. No, it's too damn long. Optional -2. Okay. Let's do this one. Let's knock out these particular, fixes. So let's try this, right? And see what happens. Okay, we get a bunch of long packets, okay, but I think we're probably just missing stuff then. Oh yeah, no, this is totally broken, yeah. No. Oh, PES data, hold up. Let's do the same here. Right, PES data, and then we do PES data instead of that. Let's chop it off the end. Just because, I don't know, like maybe there's less important information there or something. Oh, PES. Oh no, this is just the actual like audio video payload. So who knows? Yeah, it's neither here nor there for that. I mean, let's do this just to see, right? With the data, PES. Whoa. Interesting. All right, well, I think pretty much concludes the experiment, at least for now, because I don't know, it basically just looks like we just didn't receive the packets, right? Like we didn't receive the UDP packets. So the other thing that's possible is that this camera can actually do RTMP streaming as well. But, you know, then you're doing RTMP, which is all a bit, I don't know, it's all a bit weird. Like, so I think probably I'll need to just I'll just run an HDMI cable or something. I don't know, like I'll work something out. Yeah, but it's interesting, I guess. Yeah. Yeah, exactly. Yeah. Because, well, and also remember, like we did a, you know, TCP dump, and we just, you know, like we just didn't have stuff there that we were expecting. But so yeah. That it was interesting though, right? Like it was a dive into, yeah, I guess so. Yeah, yeah. Like, is that maybe, I know it's just, I don't know about getting a longer cable though, because these cables can be really, you know. I think I've got a longer one though, so I think. $30 meters. Well, I don't need that long. 5 meters would be it. Yeah. Yeah, 5 meters would do the trick. How much was that? $20? Nice. Now I think I've got one, so I'd probably go and grab that first. I could actually like literally just ride my bike up to, because I just ride a motorbike, so I could just ride because it's at my somebody's house, my sister's place or something, I can't remember where. But I could just get that and come back, because I've not had any bloody lunch because of this fucking thing. But no, look, I mean, super interesting, right? Like I've learned a lot. I've kind of reminded myself about how this thing works, and you know, it's interesting, right? Like the problems of, you know, the 90s. You know, this was MPEG transfer stream released in 1995. We're here 30 years later. You know, and yeah, I guess, you know, it's kind of interesting how it works. Of course, you know, given the amounts of data and, you know, over the LAN, I think TCP would be, you know, okay, right? Like, but again, I actually don't think it's that. I think it's something to do with the camera, because there's certainly enough. Yeah, I don't know. Yeah. it's, I don't know. I feel like, yeah, I don't know. Maybe the thing just can't pump out packets fast enough, and it's probably like a buggy. Yeah, I don't know. Hey, how you going? Yeah, sure. Absolutely. I may not even get the cable if I, well, I don't know whether I'm bothered or not. Like, I mean, main thing I'm concerned about is the audio. I can do other wacky stuff with cameras and all that. I can actually get, I can use my OpenBSD laptop. If you grab that file with the Ultra RFC 8216, it's related to that. Oh yeah. Okay. Oh, okay, cool, cool. Okay, let's have a look. So let's open up the issues. So this is HLS. Looking to have. It's a good question. Right now, so the question is about, so now we're going back to HLS. Okay, so a HLS file looks like this. And this is what's used by a lot of players, you know, like streaming services, all that, a way to, you know, read, a way to play live or like on-demand audio, video, stuff like that. Plain text file, new line delimited. We have a bunch of files in here because we've written a parser for this file. And so we've got, you know, sample files in here that have a bunch of, you know, tags in them. One, there's another tag. So every line that starts with a hash and then something is a tag. Gives some information about the stream, telling you like, oh, you know, like, if you've got this kind of bandwidth, you should read this stream. If you've got, you know, a lower bandwidth, you can read that stream. That's what it does. So what that dude from Australia is asking is, well, we have an issue. I wrote up an issue just the other day about the like main developers of the HLS spec. That's Apple. They provide a bunch of like sample HLS, so M3U8 files, and that'll be cool because then we can like run our little package against it and see if, you know, the structures that we decode out of the files are what we expect. Right now, I've just kind of randomly made some stuff. For example, we've got a frame rate one here because there's different kinds of frame rates. So there's stuff with decimal points, without, with zeros, with a comma, with blah, 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 all this stuff. So I've kind of made this file to be, you know, to be able to test that. So that dude from Australia is asking, hey, like these playlists, all of these samples, like, do we need different playlists for all the different types of tags? What's the strategy? The strategy is there kind of is no strategy. I think I just wrote these up at the time as we were writing the code and just being like, oh, like I need to parse resolution. Okay, let me just write a quick thing that does that. Part of the issue is that the way the parser is written, it's not super duper easy to test the parser just on like raw text, because the parser actually is reading in tokens from Alexa. So I guess, I think anyway, like last time I looked, just last night or whatever. Yeah, so there's no real strategy here. If rather than have whole files to read, I wouldn't mind instead being able to just test individual tags, like strings, just a line. But I, at least thus far, haven't. Yeah, yeah, being able to test like just a specific tag, just as a raw string in Go, like a Go string, you know, like in source code, you know, going like, you know, would be better. Yeah, that would be cool. I can't think of a quick way to do that off the top of my head, the way the Alexa is written now. There'll be a way. I just parse, like, let me have a look at this. So parse. See, because each, say for example, you parse a variant, which is like which comes from a tag. It reads in these items from the Alexa, and it kind of loops through, you know, just reads them through the channel. See, so we're kind of getting, you can sort of start to recognize, you know, like a variant like this bandwidth, you know, this variant, like there's a variant for this bandwidth, there's a variant for that bandwidth. There's variants for, you know, oh yeah, the codecs that we have are, you know, these ones. So right now, for example, like how do we test parsing the variant? Right, so let's go like here, if we go parse variant in all of the test files, the answer is we don't actually do it. So if we do go test cover and actually see what, it's probably not. Only 60%. Well, yeah, well, no, I mean, we don't know, no, not necessarily. What I guess, the way that I guess what we're really talking about is how to test, you know, these sort of the bits of the code that parse different tags. So here's a function that, now ignoring the implementation, what it does is it, you know, it'll parse a, the variant tag. So this variant, for example, is somewhere here. I'll just go doc variant. So the variant, this data structure represents this particular HLS tag. And we've got a function that will parse that from some tokens. The thing is that how to test that, right? Right now we're not testing this individually, which is kind of annoying, and it's not great actually. So this isn't well tested. I don't think it's and it probably points to some like design issues, I think. So probably what we'd want to do is basically like this function should maybe, I don't know, like we could probably, off the top of my head, one way to do it would be we could generate like a sort of fake item channel from a raw string. But yeah, but right now it's too difficult to add test cases for each tag. Yeah, so that's, yeah. I'm just thinking whether, what do you think? Have you got any ideas on how to? Yeah, awesome. No worries. Yeah, I think, yeah, I don't know, basically. Yeah. Yeah, I may, what I think I would do here is try and look at some other projects written in Go and see like how they handle this kind of thing. Because I guess right now I'm saying I'm a little bit out of my depth. The project that I would be interested to look at would be that one. That's interesting. Russ Cox gave a talk at GopherCon AU at the end of last year, so 6-ish months ago, and included a few examples. And Russ gave a talk on testing in Go, and it was really useful. He had a few examples from this Ivy project, and yeah, that has some like interesting testing techniques in there that is gonna be related to this, especially because the design of this Lexa is itself from a talk that Rob Pike gave that I thought, oh well, it's super interesting. So that's how this Lexa is designed. I think I actually have a link to that itself. Yeah, it is. I'll link that in a sec. I'm just gonna, so the Lexa, yeah. Okay, so the Lexa, so the design is described in this particular talk. That's linked there. And then we'll go to the actual GopherCon Thanks, mate. You're always there. Yeah. So I'm kind of thinking, oh, sorry, if we go back to, well, let's close, keep that, rid of that. Oh yeah, awesome. Yeah, like, yeah, whatever you, yeah, like, cool. That's what it's here for, right? Like, yeah. Yeah, that's that. Yeah, yeah. Um, yeah, there's a few different bits and pieces. Yeah, like if you want to go through anything, yeah, just yeah. But I should just say, shout out to that dude from Australia who has submitted a couple of useful patches. So thanks very much. And yeah, I mean, it's awesome, right? Like we're not, you know, it's I'm learning a lot. So, and hopefully that also helps other people too. But yeah, for that M3U8 stuff, yeah. No, it's all, yeah, yeah. I think, yeah, but you've picked a, yeah, like you've made it obvious, like the deficiencies in the, yeah, like there's some stuff that's, you know, like you got little, the session data, we've got some stuff like that. So yeah, yeah, I'd need to have a look through and just see like what. Yeah, so some bits and pieces we do get. Like, look, see here, this even. Oh no, the rates, yeah, okay. No, we got that. Yeah. Test. It's here, really. We want to make it easier to, like, ideally we want something like, you know, I mean, just doing it just raw now, we'd go like, you know, we'd have like a string that's, you know, like some variant, you know, for example, stream inf or something, I can't remember what the tag is, and then just some, you know, blah, 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 you know, equals blah, you know, whatever, just stuff, right? And then the corresponding data structure that we want out of that. That is really what we want. We want something like that. You know, and then some, you know, like blah, 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 just some fields, blah, blah, and then, yeah. And then just have a whole bunch of these. but right now we don't have a way to write this kind of test. Yeah, we don't have a way to write this kind of test case yet. That's really the issue. Yeah. Now adding those examples from Apple, yeah, that's also that, yeah. Like that's also important too. But maybe not as important as this. Because whatever issues we do pick up from trying to decode those playlists from Apple, you know, unless we're able to do this kind of test, then it's just going to be annoying. It's going to take time, and it's going to be like, you know, you're going to have like this huge file, and you're like, oh, I just want to check this one little byte is correct. It's like, no, it takes too long. We want to write code to do that boring stuff. You know, code is good at that. Yeah. Okay. So, on that note, yeah, that's, yeah. Yeah, but even just the tag, like even the one line, because you can, yeah, that, because right now we can't even test one. Like let me put it this way, like right now, at least let's have a look. Let me check this again. Say rendition, right? Yeah. So I think all of these parse functions. Let's do this, right? Grep. There we go. That answers that question. So right now, it is. You got it. That is absolutely the reason. Yeah. Let's see. Right now, all of these. It's yeah. Right. So then we go. So those. Let's do the issue now, shall we? Actually, it's just these ones. even know what that looks like. So we go here, test data, G string inf. Oh, well, that's fucking good, isn't it? See, we're not even testing it anyway. Okay, so there we go. How's that? Extreme inf, okay. Oh, there we go, frame rate, okay. Okay, the resolution would be, ooh, can't remember now, what's that? Oops. Okay, that's what we want. And actually then we'd also want the URL as well, so that would be there. Right, and then the URL is URI, or what do we call it, where's that variant? Ooh. URI. Yeah, something like that, yeah. We could Ooh, okay. Yeah. Okay, I really need to eat and have dinner or lunch or something. So, yeah. I'm gonna do that. Okay, so we've written that issue up, and yeah, all right. So I might, yep, let's call it for today. Thanks everybody for sort of sitting through that troubleshooting. That was kind of interesting, an interesting exercise. No good results from it other than I'm going to go up and get an HDMI cable, which is what I kind of expected, but I thought maybe, I don't know. Yeah, it's interesting what was going on with the camera. That's cool. Yeah. So yeah, thank you. As always, if there's anything people interested in seeing, then yep, just let us know. There's a is that the thing? Yep. We've got the link to the mailing list in the little scrolling text. Yeah. Tomorrow should be interesting, okay? Tomorrow I'm going around to my friend's place and maybe I can convince him to hop on the stream. But what we're going to be doing is we're going to be doing a pair hacking session. So he's going to be there with his computer, I'm going to be there with mine. And he's written a Mac application to transmit raw audio over the network. And he's going to use my the package that we've written to transmit RTP and SDP as well, session description protocol, real-time transport protocol. He's figured out a way to grab raw audio from the microphone in macOS, and we're going to transport it over RTP to some other device like my device. And we're going to do a 90s VoIP, voice over IP call using raw uncompressed audio. So it should be interesting. Yeah, it's the same way as how, if you do a normal voice call over, your normal mobile phone, it pretty much works the same way with RTP and all that. So yeah, that could be fun. There's going to be a bit of, we're obviously going to hit bugs. We're going to have weird sort of latency issues. We're going to have weird feedback. We're going to have weird clicking noises and all sorts of stuff that I think I've started working through, but who knows what's going to happen, All right. So until that time, which is going to be in about 18 hours time, I'm going to say goodbye and thanks again. And yeah, see you all. Yep. See you all tomorrow. So tomorrow, that means 16, so 1700 now. So about 18 hours time. All right. Cheers. Thanks. See you, everybody. Have a good morning or good afternoon or very late night if you're still up in America or something. All right. Ciao. I could close from here, can't I?